Hello Year 10. I thought I'd just take a moment to record the answers to these questions that you've done on X-rays and the electromagnetic spectrum. So here we have the X-ray, we've got a photograph of an X-ray, and it asks you to look at the photo and answer the questions, and they're about the properties of X-rays. So it says, explain why the teeth of the patient in the photo seem to show up more than other parts of the head. Well, that is simply because your teeth, or the enamel of your teeth, is very dense and it absorbs more X-rays than the soft tissue. Okay, so other hard substances like your bone will absorb the X-rays, and what happens is the X-ray shows black where the X-ray film, that is, shows black where the X-rays have got through, and white where the X-rays did not make it through. So here you see the white teeth because the enamel is very dense and it has absorbed more X-rays. So why do doctors advise patients to have an X-ray only when it's really necessary? Well, that's because X-rays are ionizing radiation, which means that they can cause mutations to cells. And just having done a quick mark of some answers, don't forget UV is ionizing, ultraviolet, but it can only affect the skin cells, so it's likely to cause something like skin cancer, not within the body. X-rays though, because if I draw you a little sketch, if we have our X-ray camera here, so there's our camera, those are our X-rays. Then we have a person here. Okay, there's the person, that's their nose, by the way, just in case you were wondering. Okay, and here underneath them we have the plate or the film. So those X-rays go right through the person, okay, and right through the soft tissue. They might be absorbed by the hard, dense areas, but they're going right through the soft tissue to get to the plate. So actually, you can ionize cells at any point in the body using X-rays. So we minimize and only have an X-ray when it's absolutely necessary because it's an ionizing radiation. So we want to reduce the risk of mutating or damaging cells. Okay, now the next question says, what precautions do the technicians operating X-ray machines need to take to work safely? Well, they are behind a screen, or they wear lead like a jacket if they're in the room, and those are both to stop the exposure to X-rays. Now, beneficial uses of X-rays. Using radiotherapy might be a better option than surgery. The reason why we don't want surgery is because it's invasive. That means you're opening up the body, so you're running the risk of having an infection. So X-rays are non-invasive. And also, we can target the unwanted cells with the X-ray. So we can really make sure that we're only dealing with one place, rather than if you're having to cut through something else and damaging other things on the way. Explain how the type of radiotherapy works, i.e. how can the patient's cancer be removed with minimal damage to the patient's organs. So what they do is they focus using something a bit like a lens, like we focus like with a lens. We focus the X-rays into one point, and they also rotate the X-ray tube. Now, why do they do that? So let's go back to my little diagram of the head. There we go, beautiful. I should be doing A-level art. What do you reckon, guys? So here's your camera, and when it's in this position, it puts X-rays. So say we've got something here we want to deal with, it puts X-rays there. I'm going to change colour to make it clear. So our X-rays come down and go through at that point. As it moves round, our X-rays still go through that point. Sorry, trying to draw and talk, never a good idea. Okay, can you see that this bit that we didn't want anymore has received lots and lots and lots of the X-rays, so the cells will be killed. But the rest of the healthy tissue around the outside has received much less of a dose. Okay, and so that means we can have minimal damage to the rest of the organs, maximum damage to the cancer or the tumour or whatever it is that we want to get rid of. Okay, now next questions. X-rays and waves. You've got an X-ray image of a skull there. Correct answers to complete the sentence. When X-rays enter the human body, soft tissue transmits. Okay, it allows the X-rays through it, and bone absorbs. Okay, it doesn't reflect, it absorbs the X-rays. Complete the following sentence. The X-rays affect photographic film in the same way that light does. Yeah, okay. So change the film in the same way that light does. The table shows the total dose of X-rays received by the human body when different parts are X-rayed. So we've got this is in arbitrary units. Okay, always read your title. Dose of X-rays retrieved by the human body in arbitrary units. So the head 3, the chest 4, the pelvis 60. Calculate the number of head X-rays that are equal in dose to one pelvis X-ray. Okay, so we've got arbitrary units. We know the pelvis is 60, and we know the head is 3. So how many head X-rays do we need to get 60 arbitrary units? And so we're literally just going to divide those two numbers. So we have 60 divided by 3, which is, oh, sorry, I can't write, 20 head X-rays. Okay, so 20 head X-rays is the same as the pelvis X-ray. Now, which one of the following is another use of X-rays? Cleaning stained teeth, killing cancer cells, scanning of unborn babies. Definitely this one, not that one. Why do you think we don't use X-rays to scan unborn babies? Well, what we've said is that X-rays are ionising. And the one thing that's happening when a baby is growing inside the mother's womb is that there is a huge amount of cell division and growth. There's massive growth rate going on. Imagine what would happen if the X-rays ionised one of those cells so it started producing something that it wasn't supposed to. Okay, it could have a massive effect on the baby. All right, so that's why scanning of unborn babies is ultrasound, which we're going to do in a couple of weeks' time. Okay, cleaning stained teeth, also ultrasound. Okay, basically vibrates off the dirt, but there we go, we'll come to that another time. Person can see an image of himself in a tall plane mirror. So here we're looking at your wave properties. The diagram shows how the person can see his hat. Okay, which point A, B or C shows the position of the image of his hat, and it is C. Okay, the image will appear the same distance behind the mirror as he is in front. On the diagram, use a ruler to draw a light ray to show how the person can see his shoe. And this is where everyone's stole. Do you know what? This is the joy of having everybody working at home, isn't it? My children have stolen all my rulers. I'm going to have to do what you boys do in class. I'm going to have to use a pencil. Okay, a ruler, a pen to be my ruler. So what we've got here is a light ray coming from his shoe and being reflected into his eye. Okay. And don't forget, by eye, we should see our angle of incidence and our angle of reflection as being equal. Where would he see the shoe? Well, he'd see it down here. Okay. So hopefully that helps. And which one of the words in the box is used to describe the image formed by a plane mirror? And it is, oh, I'll show you the answer, virtual. Okay, we cannot, it's formed by virtual rays. All right, it is not formed by a real ray, it's formed by a virtual ray, and therefore it is a virtual image. There we go. Hope that helps.